Well, in this case, we were gonna calculate the distance between two straight lines. This may be one of the more difficult distances to foresee somehow, depending on the lines we are working with. In this case, we are going to learn about two different cases. In the first one on the left, we are going to calculate the distance between two parallel lines. And on the second one, we are going to have two lines which do not intersect, but they are not going to be parallel. Okay. Well, let's start with the first one. In this one, we are going to have the dotted line is going to be fixed and the other one is going to be floating. And these lines are parallel, okay? Since the second one is floating, if we move it, we can see that it could even intersect with the fixed line. In this case, the distance between the two of them will be 0. So this is not the case we need to solve. Well, to be sure that the second line is not intersecting, the first one, if we set the parallel relation between both of them, we are sure this is not going to happen because the intersection point will be in the infinite. Well, so to measure the distance, as we already know, we need to draw a segment connecting both elements, and we need to set the perpendicularity relation between both the segment and the lines. In this case, since both lines are parallel, we already said that that relation. As soon as we make the segment perpendicular to one of the lines, it's going to be already perpendicular to the second one. We can check this measuring the angle between the segment and the second one, and we can see that it's already a 90 degrees angle. So something that is important is that since with only this relation, perpendicular relation is enough to define the perpendicular relation to both because the lines are already parallel, it's quite important not to define more relations than necessary in this software because sometimes the software gets a little bit crazy with if we set more relations than necessary ones. Let's see now the second case. This is maybe one of the most difficult cases to foresee. In this case, we have two lines which do not intersect and are not parallel. We are going to undo the construction to redo it together. Well, we can see that the second line, which is the floating one, is not. We have already drawn the segment connecting both. And we need to set, as we know, the perpendicularity between the segment and the two lines. In this case, we do need to set this relation in the two cases. We do it with the first fixed line with the segment, and now we do it between the second floating line and the segment too. Now we measure this dimension. It was already 30, we could set it to any number we would like. And now if we observe, we can move around, of course, moving the point contained in the second line and the segment, we can move it around. The surface that this line is going to draw when we move it around the fixed segment is going to be a hyperboloid of revolution, okay? Revolution, okay? This is, as we mentioned already, is not a very easy movement to foresee. So that's why it's not very easy to work with these examples in future problems. So it's very important, this example. And on the first case, we can see that it's much simpler because the positions of the second line are going to be on the surface of a cylinder. We can make visible now for you to see it clearer. And in the second case, we can see the hyperboloid of revolution. Yeah, we can observe how the second line defines while rotated around the axis this hyperboloid. And if we check the planes perpendicular to the axis cutting this hyperboloid, the circumference rated on one of these planes, the smallest one perpendicular to the surface, to the axis, will be the one defining the distance between the two lines because it's the shortest distance. When we work in future problems, more complex, we will need to find a line sometimes at a certain distance from a fixed line, and with also fulfilling another relations with other elements. No? So this to understand this example is important because as we are saying, it's not very easy to foresee without making this drawing all the positions that this second line could be taking. However, in the first case, since the two straight lines are parallel, it's more or less easy to identify the positions that the floating line will occupy, fulfilling the distance between the two of them fixed to 30, for example, or 15 in this case.